Shami doctor, ഒരു മിനിറ്റ്. Dr. Nandini, you may start now.
Hello.
You may start now.
Can you hear me? A warm good evening to one and all. Welcome to first section of IHMA Competitive Exam Coaching Program 2023-24 conducted by IHMA School of Homeopathy, an intense coaching program for 1 year to crack APGT. Let's be together have a silent prayer for the remembrance of our master Samuel Hahnemann.
Hello, Dr. Nandini.
IHMA, as you all know, is a premier organization of qualified homeopath of India with the chapters in many major cities and in UAE too. Our motive is global acceptance of homeopathy and strive continuously to enhance homeopathy's inherent strength for safe, effective, and affordable health care for the wellness of humanity. The academic wing of IHMA School of Homeopathy is led by Dr. Jibil P., Director. Aims at imparting meticulous personal training for developing skills necessary for successful homeopathic practice. The academic wing of IHMA takes care of coaching and training for competitive exams like PSC, APGT, etc. through CECP and most. For those who cannot afford a long-term coaching, TORCH, that is training and orientation for competitive exam in homeopathy, is held each year, which is an intense 7-day in-house and intensive coaching program. The School of Homeopathy has also released guides comprising 4 volumes named iBasic. iBasic is a book for advanced studies in competitive examination. It's an inevitable reference guide for every homeopath attending competitive examination. Its 6th edition, which is a nutshell of BHMS, containing more than 60,000 high-yielding points to help competitive exam preparation. This guide has already acquired the best status among the students and practitioners alike. The School of Homeopathy also supervises regular continued medical education program for the members by arranging seminars with competent faculties in the field. Now, about CCP 2023-24. Courses in all 2 formats. First is online and next is hybrid dual mode. It includes 10 offline classes. Offline centers are at Calicut, Ernakulam, and in Trivandrum. Course overview. Course will be conducted in the timely manner with the schedules covering the entire syllabus. Our course offer conceptual video lectures by the India's topmost faculties, test series as per the latest exam pattern, comprehensive digital notes for conceptual learning, structured classes for all-round preparation, more than 150 hours of live online courses, more than 100 hours of high-yielding recorded classes, and get access to more than 200 hours of previous year CECP classes. More than 150 live mock tests will be there. Printed study notes, that's iBasic 4-volume, standard exam pattern and interface, subject-based question bank with unlimited attempts. New hybrid model offline classes with the model question paper discussions. Daily MCQ or high-yielding point discussions. Live mock test includes members in all batch before exams. Schedules of the mock test will be provided before. Assertion reasons or match the following practice test. Subject-wise revision test will be conducted. The course duration is until next APGT 2024. Fee structure. You can acquire our basic package for 4,000. Online recordings are only available and adds on exam package 50 subject-wise test plus 20 APGT model test. 4,000 rupees, iBasic for 2,000, offline classes for 4,000, live online classes for 6,000, and question banks for 2,000. Mega offers includes combo 1. It includes 150 hours of live online class plus offline classes. It contains 10 offline class plus more than 200 hours of previous ECP classes, iBasic, 100 hours of HD recordings, question bank, plus online notes. For live members, it's for 10,000 and ordinary members, it's 12,000. Combo 2 includes 150 hours of online live classes, more than 200 hours of previous ECP classes, iBasic, 100 hours of HD recordings, question bank, and online notes. For live members, it's 9,000 and ordinary members, it's 10,000. Now, let's move to our inaugural session. First of all, let me invite Dr. Jibal P., SOH Director, for welcome speech. Dr. Jibal P., former IHMA State Secretary, IHMA School of Homeopathy Director. Over to you, sir.
Respected State President Dr. Sajeev, Respected State General Secretary Dr. Parimal, my dear coordinators, Dr. Deepu, Dr. Nandini, and other coordinators, and all my dear friends and students of CECP 2023-24. A warm good evening to all. Today, I am here before you with much pride that has produced from the last year All India PG entrance examination. It's our students asked us whether actually all the students have studied in your coaching classes. I would first like to tell you that this is not an coaching institute like many others running for pride and money. We are a professional homeopathic organization trying to impart good coaching program for our members and dear doctors for their betterment in career and also helping them to achieve higher results in competitive examination. We have the legacy of giving coaching for competitive examination for more than 20 years, and this is our new edition of 2023 for now starting on. Every year we try to improve our classes in quantity as well as quality. Last year we have given higher importance for more number of hours for covering maximum topics in all India PG examination time syllabus. This year we will be keeping upon improving the quality and the hours of classes for you for a better study. Also, this year to improve the standards of education and help to ease in higher understanding of the topics, we are already setting in the process of setting up a high definition recording studio, and the program of developing it is under process and will be out soon. Now, let me go into my duty today. First, I would like our State President, Dr. Sajeev, to the meeting. Now, I invite Dr. Parimal Chatterjee, our State General Secretary, for the meeting. I invite Dr. Deepu for this inauguration meeting, and I invite all my dear coordinators, and not but not last but not least but last but not least, I invite all my dear students for not only for this inaugural session but into this year coaching program. Welcome all. Thank you.
Thank you, sir. Next, let me invite Dr. Muhammad Shabi, President IHMA Kerala, for the inauguration of our program IHMA CECP 2023-24. Over to you, sir.
Good evening. Respected General Secretary Dr. Parimal, SOG Director Dr. Jibil, Dr. Deepu, SOG coordinators, and dear doctors. I am honored to inaugurate this year's IHMA CC program. I am sure this will be a game changer for your life. Each and every minute of this ECP session will add your knowledge and reduce your gap from achieving MD admission. I am not talking much time, as you all are eagerly wait this academic session. I am wholeheartedly inaugurating this session. So I am officially inaugurate this year online CCP program. Okay, thank you.
Thank you, sir. Next, I call upon Dr. Parimal Chatterjee, General Secretary, IHMA Kerala, for delivering keynote address. Over to you, sir.
Hello, am I audible? Hello.
Yes, sir. Yes, sir.
Okay. Good evening, respected State President Dr. Sameem, School of Homeopathy Director Dr. Jibil, Dr. Deepu, most coordinators and colleagues and friends from homeopathic fraternity. As we all know, we are beginning the CECP course for the year 2023-24 from today. IHMA had been bagging the best ranks in the APGT exams in the last years. We have a very well-equipped faculty pool, and we are having coordinators to arrange the CCP course, who had been the backbone of IHMA always. I wish you all a very good success in the coming CCP 2023-24. It will be, as our state president has told, this will be a game changer in your life, and we wish you all success, and your hard work will definitely be paid during this year. Wishing you all the best. Thank you.
Thank you, Doctor. Next, I call upon our stars of the day, APGT first rank holder, Dr. Alim Sarah Alex, to talk about how to crack APGT tips and tricks. Over to you, Doctor.
Am I audible?
Yes. Yes, Doctor.
Okay. Hello, good evening to all. I'm Dr. Alin Sarah Alex. First of all, I would like to take this opportunity to thank God Almighty for this great success. I also thank the entire team of IHMA for having me here. I would like to start by wishing you all the very best for the coming APGT 2024. May you all be able to prepare well and achieve great success. In this session, I'm here to share a few points that helped me during my APGT preparation. First of all, I would like to talk about the exam. I think all of you have an idea about the exam. The exam has 120 questions, and for each correct answer, you will get 4 marks, and for each incorrect answer, you will lose 1 mark. Also, we have seen that over the years, the exam is getting tougher. But what I think is the key to crack this exam is making the concepts clear from day one and then working out as many MCQs as you can. Also, equally important is being systematic and consistent in your preparation. What I feel is that merely during the MCQs without learning the concepts is actually of no use because you will forget it eventually. But learning the concepts and then doing the MCQs will deepen the understanding about your concept. Also, an advantage is that you will be able to answer correctly the questions that are asked from those topics because you will have a clear understanding of the concept as well. Also, even if they frame the questions in a different pattern or if they are twisted, you will be able to answer correctly. Also, I want to encourage you all to have a study pattern from day one of your own because and also to adhere to it. Also, here you are having a very good coaching platform with excellent faculties and very informative notes. So, all of you make use of it to the maximum and also study the lessons regularly. I would also like to share an important point that is revision. You have to revise regularly all that you've learned. It's common that you forget what you've learned when the information is huge, that you tend to forget the concepts that you've learned. But revising regularly can help you overcome it. Also, always think positive and remember that you will achieve that you truly desire. Finally, I would like to say this to all those who are hearing me right now that although the cracking the exam may not seem that easy, but I can assure that with strong determination and hard work, you all can achieve it. Thank you.
Thank you, doctor. Thank you so much. Next, I call upon APGT second rank holder, Dr. Nancy Singhal, to talk about do's and don'ts while studying or writing the exams. Over to you, doctor.
Good evening, everyone. Thank you, HMA, for inviting me here and giving me this opportunity to share my views. So I will begin with this. Okay, so first of all, let's start with do's and don'ts for the preparation of APGT. So the first thing about do's is know the exam pattern. Like we all know, like as Dr. Ellen also mentioned, that the exam is getting tougher day by day. So first of all, when we start the preparation, we has to know fully about the exam itself. So like what kind of questions are appearing, what kind of syllabus is coming, what kind of subjects are having which marks, like that. We have to get the whole idea about it. So know the exam pattern will be the first thing before starting the preparation. And we have to analyze the previous year question papers also. Then doing that, we'll get to know about the exam pattern and the kind of questions that are getting asked in the question paper, like MCQs, like match the following, then assertions and reasoning, then one-liners, So like that, many type of questions have been appearing. So we can get to know about that when we will analyze the previous year question papers. Then coming to the next point, then we have to get an idea about the subject division. So we have to take a note of weightage of each subject. Like for example, like materia medica, then this practice of medicine, pathology, surgery, and obs and gynae are like about 16 to 18 questions have been asked from these subjects. So like that, after analyzing the previous question papers, you'll be able to get to this information, like which subjects are carrying how much weightage in the examination. So accordingly, you can know their importance in the preparation. So you cannot miss out any portion from those subjects. So you have to take a note of those things. Then the next thing is you have to prepare a roadmap. Now, what I mean by roadmap is, as we all know that without plan, it is easy to get sidetracked and lose focus. So without before starting the preparation, we have to make a plan and we have to move according to a strategy. And for that, we have to prepare a roadmap. Now, what I mean by roadmap is, like, before starting the preparation, we have to get a hold, like how many months do we have for the preparation? Like if we count hardly, like if we start preparation by now, so we'll be getting 9 months for the preparation. So accordingly, we have to divide the time for the preparation of the subjects, then for the revision of the subjects. So say for example, if we kept 7 months for the preparation, then we have to take out the time of 2 months, at least 2 months for the revision also. So like that, you have to plan, and this thing might change according to individual, and the strategy might change according to the subjects also. Like one might be good in one subject and one might be good in another subject. So like that, you have to prepare a suitable strategy which suits you and which you think will be able to help you in the preparation. But you have to prepare a strategy before starting the preparation so that you can get a hold of yourself, how you're standing, where you're standing in the preparation. So coming to the next point, the next point is obviously do smart study. As we all know that APGT, like every year, it is getting tougher, and we know that the examination will be having entire 4.5 year BHMS syllabus. And for preparation, as I mentioned, we just get 7 months for the actual preparation. So it's impossible to go through all of the things in just 7 months, like 4.5 years syllabus in just 7 months. So we have to make a note of it. Like we have to go through the important points. We cannot prepare like we prepared for the BHMS. We have to change our strategy for this because we have to because we have to cover a major portion. So we can make as many mnemonics as possible. We can take the help of diagrams, flow charts, and we can highlight the important lines to make ourselves aware of what is important while doing the revision so that we can stress upon the points which are necessary for the exam, which will eventually going to help in the preparation also. Next, coming to the point is practicing MCQs for each topic. So whenever we are taking one topic, if we are solving the MCQs, so it will help in our preparation also. How? Like when we study the topic, when we read one topic, we tend to overlook something. But when we solve the MCQs after reading the topic, then it gives us an insight of the things which we have overlooked. So when you like when you will solve the MCQs, you'll get to know those points which you tend to overlook while you study the topic. So what you can do is, when you do MCQs and when you get to know about the mistakes or when you get to know about the things you overlook, so you don't have to take stress of it. You just have to highlight those points, and you can add on or you can highlight those lines so that when you come back to that topic for revision, you'll get to know that is the thing which you have to remember again. So like that, solving MCQs can help you to take your preparation to the another level. Then the another thing is like materia, if I say, revision is the key for the material also, because we know that material is a vast subject to deal with. So revision is a thing, and then learn the drugs, but we tend to overlook the some symptoms of that from the materia medica. So what you can do is you can solve, like you can set a target of solving 100 MCQs a day. So when you solve the 100 MCQs, you will get to know there will be some symptoms which you might overlook while reading those drugs. So while solving, when you get to know about those MCQs or those one-liners, you can go back to the drug itself, and then you can add there that particular symptom. So when you will be reading the drug, you'll be getting more insight of it, and you'll be able to do better than before. Then coming to the next point, the most important thing is be optimistic and stay focused. So we know there'll be times when you'll be feeling low to the preparations, but you have to hold on to that and you have to keep going. So, and stay focused is one thing which you have to work on, because you'll get many distractions while preparing for this exam. So give yourself small breaks while preparing. Don't overexert yourself. Keep yourself concentrated. So to make that concentration, you can give yourself small breaks. And then coming to the next point, encrypt your study with the key of revision. So why I say this? Because a study is not complete without a revision, and revision is the key to success, that we all know. Because we keep on learning new things, and we'll keep on forgetting what we learned before. But to strengthen what we learned today, we have to revise it. So that's why I said encrypt. We have to make it lock in our mind. Like when we come back to the topic, the things which are important will be revised, and they will be locked in our memory. So will not have to worry about that. So revision is something which we cannot forget. You can take a day out of the week, and then you can like do the revision of the whole week on that particular day. It will help you in the preparation. Then coming on to the next point, that is follow the mantra of the success. So we all know the preparation can be done without the hard work, and there are no shortcuts for this. So you have to do the hard work, and you have to be consistent, and the perseverance you have to be have that. And there should be no room for the procrastination, because we keep on delaying. So what you have learned today, take a hour out of it, and then just go through what you have learned throughout the day. It might be tiring, but it will help you to secure what you have studied for the whole day. And in end, you'll get the confidence also. So that's all about the do's. Now next we'll come to the don'ts. Okay, so first thing is we should avoid doing is going through the multiple study materials. So like we'll be hearing from the seniors, or somewhere we'll find that, oh, somebody mentioned that this book is good for the preparation. But what I'll say is stick to one book and read it. Like if you're reading one book for 5 times, it's a still good idea than reading 5 different books at once. Because when you will keep on revising, when you will keep on seeing the text again and again, those things will stick onto your mind. And the presentation of a book, if you like, it's your choice, it's your call to choose one book which you are able to understand better, and then stick to it. Revise it more often. That's it. You can do in spite of switching between the books. That will help in the preparation. Then next thing, avoid the mug up learning. As we know, the questions are coming up more conceptual based. So for that, this bugging up will not help. So we have to build our concepts, like Dr. Ellen also mentioned about that. So we have to make our concepts crystal clear before starting the preparation itself. So that is one thing we have to take note of. And then don't give test without preparation, because if we'll appear in the test without preparation, it is more likely that we will not able to get good marks out of it. So you might feel demotivated after giving that. So it's better to prepare, and after that you can go through the MCQs. So in that way, you'll get to know about the things you overlooked or about your mistakes also. So it will help you to learn better. Then the next thing is not taking care of health. This is the mistake we tend to make in when we prepare. So we have to be very vigilant in that we have to keep ourselves healthy. So we have to get enough sleep, and we have to eat healthy thing like food also. And along with that, we have to do regular exercise. We cannot miss on that because it boosts on your energy to prepare well. And the thing is, next thing is, don't get demotivated. Keep yourself motivated, because when you will feel motivated, you'll feel the energy to go on with the preparations, which will help you to get to that success. And at last, I just want to end this with the quote that don't just learn, experience it. Don't just read, absorb it. Don't just think, ponder it. And don't just dream, do. And thank you very much. And I wish all the very best for all the future aspirants. Thank you.
Thank you, Doctor. Thank you so much. Next,
Thank
I call upon APGT third rank holder, Dr. Nancy Saj, to talk about important topics to be covered in APGT. Over to you, Doctor.
Am I audible?
Yes, yes.
Yes, Doctor. Yes.
Good afternoon, everyone. Myself, Dr. I can't able to start my video.
Okay, okay. Continue.
Good afternoon, everyone. Myself, Dr. Nancy Saj. I'm currently pursuing my internship at Government Homeopathic Medical College, Trivandrum, and it will be over by October last week. First of all, I thank you, EHMA SOH team, for giving me this opportunity to share my views on important topics to be covered in AIAPGT. First of all, I extend my gratitude to the Almighty for giving me this success, and my parents and the whole team of IHM SOH for helping me to achieve the great success. Today, I am discussing the weightage of each subject, which has been currently followed by this PG entrance exam. First of all, there are homeopathic subjects and allied subjects. Homeopathic subjects covers about 50 plus questions in each year. This year, there were 56 questions from homeopathy itself. All other questions are from allied subjects. So when we analyzing the previous year's questions, 2000 for each subject from 2021 to 2023, 3 years. In 2021, homeopathic subject, first we have to cover the homeopathic subject. 16 questions from MM, 14 questions from OM, 17 questions from repertory, and 7 questions from pharmacy. Then from allied sciences, allied medical subjects, PM, practice of medicine, 23 questions, gynecology 10, anatomy 6, physiology 10, pathology 10, surgery 1, preventive medicine 2, forensic medicine 3. In 2022, the weightage was very similar, that Materia Medica covers about 17 questions, OM 15 questions, repertory 17 questions, pharmacy 7 questions. Similarly, 22 questions from practice of medicine, 9 questions from anatomy, 6 questions from physiology, 3 questions from pathology. Forensic medicine has 3 questions, surgery has 6, OBS and gynec has 10 questions. In this year also, the same weightage, that is homeopathic subjects has a equal weight of MM 18 question, OM 15 question, repertory 17 question, pharmacy 6 questions. Then from medical, allied medical subjects, PM should cover most, means majority of questions, that is 17 questions from practice of medicine. Then 11 questions from gynecology, 8 questions from anatomy, 7 questions from physiology, 4 questions from pathology, 8 questions from surgery, and 6 questions from preventive medicine, and 3 questions from forensic medicine. From analyzing these previous questions, it's clear that without a knowing concept of allied medical subject, we can't clear the PGT in first or second chance. This is because only 50 plus questions are from homeopathic subject. All 60 or more questions are from allied medical subjects. So when we are only orienting our attention to the homeopathic subject, we are missing majority of the other questions. Only 50 plus questions answered does not give a chance for PG exam. Then we have to cover all the other subjects also, not only give attention or importance to the homeopathic subject, we also have to give importance to allied subjects. From these allied subjects, practice of medicine have majority of means high chance of asking more questions. So from each subject, what we have to look for, then first we have to look for homeopathic subject. In Materia Medica, we have to thorough with keynote. First, we have to thorough with keynote. In keynote, first we have to understand the family name, prover, common name of each drug, and then we have to give importance to relation part as well as the points given in the bracket. Then after the keynote, after we understand thoroughly the keynote, then we have to move to boring. In boring, we have to clear first the points given the first paragraph and also points in italics. We can't mug up all the points given in boring. So MCQs will give you revision of important points in Materia Medica. IHMA has been arranging MCQs for each alphabet in each week. That will give you to understand what are the important points in Materia Medica. Then when we come to organ of medicine, most important is aphorism. This year, out of 16 questions, 15 questions from aphorism itself. Only one question has been asked from philosophy, and from philosophy part, you have to look Kent observations. Every year there should be 1 or 2 questions from Kent observation. So we have to understand our aphorism thoroughly. Then you have to look for philosophy. Most importantly, Kent observation. In repertory part, you have to achieve the basic ideas of 3 basic repertories. Then classification of repertory, evolution of repertory, years. These points are all mentioned in every coaching books, and you have to stick on to single material for covering all subjects. Then when we come to pharmacy also you have to attain a thorough knowledge about the basic points in pharmacy. You have to do smart work rather than hard work. That is, the questions which are the portions which has been more important is given in material very clearly and with the basic concept. So you have to understand it first, then you have to seek more points. So in pharmacy, you have to look for sources of medicines, pharmacopoeia, HPI, the homeopathic pharmacopoeia of India with its years, preparation of medicine, old school, new school, drug ratio and drug strength in old school, preparation of medicine, ways of patentization, vehicles, external application. There are many points which has to be covered in pharmacy. All these are given detailed in every book, and iBasic of IHMA also provide a detailed description of these important points. And then practice of then homeopathic subjects are over. Then when we come to the allied sciences, I have already mentioned that practice of medicine carry more weightage. So in practice of medicine, you have to get a basic knowledge about each system which has been mentioned from its basic science cycles, etc. There CVS, CNS, respiratory, GIT, the basics. You have to get a basic idea about each systems in practice of medicine. In all other subjects like gynec, CM, pathology, biochemistry, forensic, FMT, this you have to only stick to the guide you have been following. This is because these subjects carry 3 or 4 questions, but you have not covered the whole portion to attain these questions. These questions is asking from the basic concept you have achieved through the 4.5 years of your BHMS course. So you have to refresh your ideas by going through the target means IHMA, iBasic or any other material you have been using. Then first you have to stick on to the basic ideas, basic concept, because nowadays the more assertion and reasoning questions have been asked, we cannot answer such questions without the knowledge of basic concept in each subject. Hard work plus smart work help you to achieve good results, and consistency and revision is the most important qualities you have to achieve there. Sometimes there may be many ups and downs during the journey of your success, like sometimes the currently going intense, sometimes how now then you have not that there may be a way, that is where there is a will there is a way, that is the quotation. So you have to stick on to your ideas and ideals, and you will achieve. So for the future participant, I wish a great success in your journey of success. Thank you.
Thank you, Dr. Nancy. It's our pleasure to be part of your success, and we wish you all the very best for your future. As we have come to the end of the session, I invite Dr. Deepu CS, IHMA Hog, Academic Chairman, former IHMA State Secretary, for delivering vote of thanks.
Thank you, Dr. Nandini. Respected State President and my dear friends, I'm here to give the vote of thanks for the business session. So let me thank our President, Dr. Mohammed Shamin, for inaugurating this session. Thank you, sir. Next, I would like to take this opportunity to thank our Secretary General for giving the keynote address. Thank you, sir. Next, I would like to thank our SOH Director, who has been inspiring for 1 year. He's continually encouraging us to get the maximum output from all our faculties, none other than Dr. Jibil. Thank you, sir. And I'm giving gratitude to all the, mainly Dr. Simi, our technical assistant, for being there for 2 years. Dr. Prashant Setigaran, Dr. Krishnadas, Dr. Israr, Dr. Nandini, and our team of SOH. Without these people, it would not be possible to attain such results. And the respected, our beloved rank holders, Dr. Alin Sara Alex, Dr. Ansi Saj, Dr. Nancy Singh. Special thanks to each one of you to take this time with IHMA SOH to give your valuable suggestions and information to the young generation. Thank you. And thanks to each one of you whoever joined through YouTube and Zoom for attending this session. Thank you so much. Over to Nandini.
Thank you, Doctor. Next, we are moving to our first class, Introduction to Embryology, by Dr. Sajeev, former director of IHMA School of Homeopathy. He had his graduation from Government Homeopathic Medical College, Trivandrum, in the year 2000 and MD in Practice of Medicine in the year 2008. He entered government service as a medical officer in Department of Homeopathy, Kerala. He had been instrumental in various projects under the Department of Homeopathy. Being an academician, he is an integral part of IHMA training programs, CECP, MOST and TORCH. It was his dedication and hard work that made IHMA could publish iBasic. He is a man with immense clinical knowledge, a busy practitioner, had been a part of many national seminars. It's our immense pleasure to have you here, sir. Welcome you to this class. And over to you, sir.
Thank you all. Thank you, Dr. Deepu, and thank you, Doctor, for giving me an opportunity to present a topic and as a first class for this 2023 and 24 CECP coaching program. So it's very happy to meet you all in online platform. So I think all of you are preparing well for the examination. The examination will be almost in the July or August 2024. So all the very best for your exams. And let me start the class directly so that you will not miss any time. Is it visible now?
Yes,
Yes,
yes.
sir.
So embryology, we know that it is one of the most boring topic in anatomy or in the entire medicine field. And definitely starting with embryology itself is a very problematic, but still I will try to make it more boring. So I will give you some basic concepts regarding the embryology. And I think most of you know the basic ideas, and I will give some more points regarding the questions that can be from which the questions can be asked from that embryology. So embryology, embryonic period, we usually divide our total uterine stage of our earlier development into embryonic stage and fetal stage. So the embryonic period is usually from 1 to 8 weeks of development. So embryology mainly concerned with that means the first 2 months of development of the embryo. Later we turn that into the fetus. So we are now concentrating on the first 8 weeks of development. And we can classify embryology for the purpose of study. We can classify it into general embryology and systemic embryology. So we are today dealing with both general embryology and systemic embryology. By systemic embryology, we are not dealing with all the systems or the organogenesis, nothing. Systemic embryology questions are asked predominantly from these 3 topics: the neural crust and its derivatives, the pharyngeal apparatus and its derivatives, and the urogenital apparatus and its derivatives. So these are the 3 core areas of systemic embryology. We are today dealing with that 3 parts and the general embryology. So the general and systemic embryology. Now we are starting from fertilization itself. Not the spermatogenesis and oogenesis are not derived. I think that will be covered in the anatomy topic. So after fertilization, we know that the fertilization takes place in the ambula of the fallopian tube. So that is the first day of fertilization. Then slowly that zygote, the formed zygote, will by the ciliary, it will not move on itself. It is by the ciliary motion of the uterine tubes or fallopian tubes, this embryo will move towards the uterine cavity. So by the second day, what is happening? That means after fertilization, the mitosis will start. That means the cleavage of the cell. From the 1 cell stage, it will go into 2 cell stage. From the 2 cell stage, it will go into that 8 cell stage. From the 8 cell stage, it will go into the 16th cell stage. That's the way it is progressing. That is pure mitosis. All the cells are of similar or same kind. There will be no differentiation in that cells. That is an important point. And all these cells will be covered by the zona pellucida. So the 16th cell stage will occur on the third day of intrauterine life. That is the first day. You can see the zygote. Then it becomes mitosis starts, and a 4-cell stage. Again, it will divide by the process of mitosis. And on the third day, the 16th cell stage usually occurs. And we know the name of that 16th cell stage, that is the morula. So the morula, it contains 16 cells. And all these cells are immature cells. No particular differentiation is happening there. So they are termed as blastomeres. Blast cells, wherever we hear blast cells, we must know that these are immature cells. That is, they are not properly differentiated cells. Here also, they are not properly differentiated cells. So we term it as blastomeres. So morula is a 16th cell stage, and it is covered by or protected by the covering called zona pellucida. The presence of that zona pellucida is very much important. Zona pellucida on the surface protects it from embedding. So that is the significance of the zona pellucida. So we must know a pathology we can think at that time is, so when that zona pellucida, so that zona pellucida will be lost when it comes to the uterine cavity. This protective covering of zona pellucida will be lost when this embryo comes to the uterine cavity. Then only it can embed on the uterine surface or uterine cavity. So what happens if that zona pellucida is lost in an earlier stage? What will happen? This embryo will get embedded in the fallopian tube, and ultimately that will lead to the condition called tubal pregnancy. And we know that that is a very surgical emergency. That rupture of that tubal pregnancy is very much fatal, and so that is a surgical emergency. So that happens due to the early loss of zona pellucida. That happens, and the embryo will get embedded in the fallopian tube. So that is a pathology related to that zona pellucida. And one more thing that I will tell later. So zona pellucida is on the surface, which protects it from embedding. And later, by the the ciliary motion, by the ciliary movement of the fallopian tube or the cilia, cilia is present in the fallopian tube, and motion of that cilia will help to move that embryo towards the uterine cavity. And the morula will pass down to the uterine tube, in 75 to 80 hours. And next, what is happening? And at last, by the day of 4th or 5th day, the embryo will come to the uterine cavity. Now, what is happening to the embryo? We must know. Up to that stage, up to the 16th cell stage, there is no differentiation of cells. But after that, the cleavage will occur, and cleavage or mitosis continues. And from this 16th cell stage, it will go into an 80-celled stage, not 18. It will go into an 80-celled stage. And at that time, cellular differentiation starts to appear. Here you can see a cut piece of an orange. The 16, you just think about that orange. The orange has a peel outside and an inner pulp. In the same way, the cellular differentiation occurs in our embryo also. The embryo now consists of an inner cell mass and an outer cellular layer. So here you can see an inner pulp or inner cell mass and outer thin layer of a thin sheet of cells. Here the inner pulp is the embryoblast and the outer cellular layer is the trophoblast. That is the first cellular differentiation occurring into that embryo. The outer trophoblast and an inner embryoblast. That is the first differentiation. At that time, still at that time, the zona pellucida is there. Here you can see. And that is the stage of, still it is present in the zona pellucida is present. Now what is happening is that some channels, sodium leakage channels will open in the trophoblastic layer. sodium leakage channels will open in the trophoblastic layer. And what will happen? Sodium and water will rush into that trophoblast or into the embryoblast. That is, here you can see, this is a cavity is formed. This cavity is formed due to the rush of fluid and sodium from outside into that area. And now a cavity is formed, and that cavity is termed as the blastocoele. Now we term this whole mass as blastocyst. So blastocyst, the name itself gives the idea that it contains a cyst. This is a cystic cavity. This cystic cavity is formed by the inflow of fluid and sodium from outside, and the embryo proper or embryoblast is pushed to one side. And now we know that that side becomes the embryonic pole of the total mass. The embryonic pole of the mass has occurred. That is due to the pushing of the fluid which has entered into the cavity. Now this stage is termed as a blastocyst. It is a 60 to 80 celled stage. It is a ball-like structure with a cavity. Now we know that the outer cell covering, that we already termed it as the outer cell layer covering as the trophoblast, and the inner cell mass as the embryoblast. So this is happening almost on the 7th to 8th day. That is the blastocyst. And this occurs due to the entering of fluid into the embryo. The space created inside the embryo is termed as the blastocoele or blastocystic cavity. And now that whole thing is termed as blastocyst. And now the inner cell mass is termed as embryoblast, and the outer cell mass is termed as trophoblast. And the most important thing to happen there is the zona pellucida is lost at that time. That is the most important thing to happen. The zona pellucida is lost. That means now the embryo is going to get attached to the uterine wall. That is the significance of zona pellucida. So what will happen if the zona pellucida is not lost at this time also? That means the zona pellucida is persisting even after the 8th or 9th day. If the zona pellucida is persisting, what will happen? The embryo will not get attached to the uterine cavity, and that can lead to infertility. So that itself is a cause of, if it is a consistently present in a lady, that can lead to infertility. So that means the embryo cannot get attached to the uterine cavity. That is a pathological thing. So the important thing is, if the zona pellucida is lost early, that will get attached to the fallopian tube, and that will lead to tubal pregnancy. That is also lead to pathology. And if it is lost late, or if it is not properly lost in the proper time, that also will lead to abnormality. That is, the embryo will not get attached, and that can be a cause of infertility. And implantation occurs on the 6th day. The attachment of the blastocyst on the endometrial epithelium, and you can see that attachment is occurring at the embryonic pole. That is, actually the trophoblast is attaching to the endometrium, and that occurs at the embryonic pole. How that occurs, we must know. The embryonic pole, you can see. The trophoblast has penetrated the epithelium and has started to invade the connective tissues of the endometrium. That is occurring on the 7th day of intrauterine life. So, to summarize the things happening in the general embryology happening in the first week is fertilization occurring in the ampulla. The blastomeres are dividing. The outer covering, that is called the zona pellucida. The cells, that means the blastomeres, they are adhered in between by the help of glycoproteins. And the 16th cell, or maybe 12 to 13th stool, that is an average. A 16th cell stage is termed as a morula. Then I told that the differentiation of cells into the trophoblast and the embryoblast occurs. And then the implantation in the uterine wall. And how that occurs? There you can see a particular name called L-selectin. L-selectin is a molecule that is found on the cell surface of leukocytes and the blastocytes. That is a significant thing. So L-selectin is a molecule found on the cell surface of the blastocyst. And we must know that our uterine endometrium has receptors for this L-selectin molecule. So that is how this embryo get attached to the uterine wall. This blastocyst contains L-selectin, and this L-selectin get attached to the receptors in the endometrium. That is how this attachment into the uterine cavity occurs. So that can be asked L-selectin. Another name is CD62L. And this L-selectin is present also in the leukocytes also, that we must know. So that is how it get attached to the uterine cavity or endometrium. Now what is happening in the second week, we must know. So we may have heard about the decidual cells. So decidual cells are the cells inside the uterine wall which provides nutrition to the developing embryo. Now we must know that the trophoblast now differentiates. So differentiation occurs. The next level of differentiation occurs both in the trophoblast and in the embryoblast. That means the differentiation occurs both in the outer cell layer and the inner cell mass. The differentiation in the outer cell layer is the trophoblast will divide into syncytiotropoblast and cytotropoblast. The trophoblast will divide into syncytiotropoblast and the cytotropoblast. That means the peel of the orange will again differentiate into two layers, the outer syncytiotropoblast and the inner cytotropoblast. And the embryoblast, that will also differentiate into two layers. And it will be seen like a disc. The outer disc is termed as the epiblast and the lower disc is termed as the hypoblast. Here you can see the differentiation into two. The trophoblast differentiate into two, the syncytiotropoblast and the cytotropoblast. Syncytiotropoblast is usually seen at the attachment with the endometrium or uterine cavity. So the differentiation of the trophoblast into syncytio and cyto predominantly occurs in the attachment sites or adherent site. That is, the syncytiotropoblast is directly attaching to the embryoblast, the endometrium, and the inner cell mass. You can see here the inner cell mass, the red colored epiblast and the blue colored hypoblast. The epiblast and the hypoblast occurs at this region. So cellular differentiation occurs in the outer layer and the inner cell mass. That is a significant thing happening in the second week of intrauterine life. So one more thing it will happen. Again, you just think about the condition. You just think that the hypoblast, the blue cell mass, it will go and differentiate, or it will proliferate and it will lie in the trophoblast, that is the cytotropoblast. Just think about a U-shaped lining by the blue cell mass. That is a hypoblast will proliferate to form a U-shaped cell mass. That is by the cavity, that is the U-shaped cell mass. Here you can see. This hypoblast will grow like this. It will grow and line the cavity. It will be like that. That is growing of the hypoblast. Here it is golden in color or yellow in color. This is a hypoblast. It will cover and line the cavity, inner lining of the cavity. Now this cavity is termed as the primary yolk sac. That is what we have now. Till now we called it as blastocele or blastocystic cavity, but after the hypoblast line that cells, we now termed it as the primary yolk sac. The primary yolk sac, and here you can see in the blue cell mass, there also a small cavity is developing. That is how, that means there also the cells will grow, the cells will proliferate, and it also will create a small cavity is created here also. And that cavity is the amniotic cavity. So now we have a primary yolk sac and an amniotic cavity. The amniotic cavity is formed by a cavity formed in the epiblast. Epi means upper, hypo means lower. So epiblast means a cavity. So that means amniotic cavity is occurring as a cavity in the epiblast. That is a space in between the two layers of epiblast that is leading to amniotic cavity. So thus the amniotic cavity is developed. The amniotic cavity develops in the embryonic cell cluster above the epiblast. That is the most significant thing happening in the second week of intrauterine life. I think it is clear. So the epiblast, the proliferation of the epiblast will lead to the, here you can see the yolk sac, the primary yolk sac cavity and the amniotic cavity has been formed. This is still, there are two layers. That is, it is termed as a bigeminal layer. The epiblast, the red colored epiblast and the blue colored hypoblast. Still you can see the primordial germ cells. That means the cells which are ultimately going to form the gonads or the spermatogonia or eugonia. They are formed at the second week of intrauterine life itself. You can see a primordial germ cell at one of the corner. So that is a significance. And at that time, one more important thing is going to happen. I think you can see me. These are two layers. You can think it as two layers. This is the hypoblast. Sorry, this is the upper layer, that is the epiblast, and this is the lower layer, that is the hypoblast. In the epiblast, at a particular region, a particular portion, these two layers are very closely in connection, closely adherent to each other. At a particular point, it is very closely adherent to each other. This is the point. You can see it as a red colored mark. At that point, it is very closely related to each other. And that is termed as a procaudal plate. The procaudal plate. And this procaudal plate ultimately develops into our mouth. That is the most significant thing. And the presence of this procaudal plate, where it is present, that determines the head end of the embryo. And the opposite end will be the tail end of the embryo. So the presence of procaudal plate is significant. It will be at which region it is present, that region ultimately develop into the head region, and the opposite region will develop into the tail region or the caudal region. And the procaudal plate you can see here. And the next thing to happen is a particular cellular differentiation. You can see here it as a line. A particular cellular differentiation occurs here and a cellular degeneration occurs. It will form a particular line of cells that is termed as the primitive streak. You may have heard about the primitive streak. And below here you can see again a cellular differentiation go downwards or backwards or caudally. A cellular differentiation go backwards, and this cellular differentiation ultimately forms the notochord. So that is the significance of notochord. The backward, the caudally positioned cells will go into form the notochord, and this one is the primitive streak. And the next thing to happen is degeneration of the primitive, the cells here. That means you just think about like this. The cells will degenerate. That means the cells will degenerate in this region. And what will happen? Now the embryo has gone into the third week of intrauterine life. Now the bilaminar, the cells will go and proliferate. It will go from this region and move into this groove, and it will fill this middle region. The cells from this region will proliferate and move into this middle region. Now the bilaminar disc has turned into a trilaminar disc. There is an uppermost layer, a middle layer, and a lower layer. And the outermost layer we term it as the ectoderm. The middle layer we term it as a mesoderm, and the lower layer now we term it as a endoderm. That is a trilaminar disc that happens in the third week of intrauterine life. That is a significant thing. So mesoderm has been formed, and there in the middle of the mesoderm you can see the notochord also. That is the most important thing. So the bilaminar disc has now turned into a trilaminar disc. It is a three-layered disc. And one more thing you have to know, the notochord is in this region, and the area now this is the ectoderm. The upper layer of the ectoderm or the upper part of the ectoderm corresponding to the area of the notochord. That means the notochord is now in the middle and the cells corresponding to the notochord in the upper region of the ectoderm, that is here, the upper region of the ectoderm, that will differentiate into a particular sheet of cells. A particular sheet of cells can be seen here. A particular sheet of cells in the upper part of the ectoderm. That particular sheet of cells is termed as the neural plate. The neural plate is formed in the upper layer of the ectoderm. So that is all these things are happening in the 3rd week of intrauterine life. So the neural plate is formed from the ectoderm, and this neural plate is ultimately developing into the central and peripheral nervous system. The central and peripheral nervous system are predominantly developing from the neural plate. And now we have to know what is happening to the neural plate also. The next thing we have to know, just imagine it as a neural plate. That is a sheet of cells. That is a neural plate. The neural plate will fold on itself. The neural plate will fold on itself to form at first a neural groove, and it will join like this. It will join like this, and we can see that the edges will join. The edges will join. It will be like this, almost like this. It will join like this. And there are some cells in the uppermost region, that is the edge region. These cells are termed as the neural crust cells. Crust means we know that the upper region. So the cells seen in the upper region, or here we just remember it as the edges. They are termed as the neural crust cells, and that is the first part. We termed it as a systemic embryology. What are the derivatives of the neural crust cells? That question can be asked in the APGT examination. So many derivatives are occurring from these neural crust cells, other than we will later learn. So the neural crust cells are developing from the neural plate. That is the significance of the neural development. The later stages of the neural development that we will study when we study the neurology. That means in practice of medicine, when we study neurology, we can learn about the later stage of neurological development. But here we are limiting to this neural crust cells only. So what is happening? The neural crust cells will develop into so many structures in our adult stage. What are the things we have to study? So the bilaminar disc in the 2nd week of intrauterine life, it has turned into a trilaminar disc. That is the ectoderm outermost layer, the middle layer of mesoderm, and the lower layer of endoderm. Now we have to again go back to the slides. So here you can see the things. The amniotic cavity develops inside the embryonic cell, that is the epiblast. Here, the secondary yolk sac, I think, the syncytial trophoblast. So one more thing you can see, I think one more sheet of cells will develop from the endoderm. That is that now it has termed as a trilaminar disc, or maybe the hypoblast. One more sheet of cells will be forming like a U-shaped form, and it will create one more cavity here. Apart from the primary yolk sac, now a secondary yolk sac also has been formed. So a primary yolk sac and a secondary yolk sac has been formed, 2 cavities, and our inner viscera is developing from the secondary yolk sac. That we must know. The inner viscera is developing from the secondary yolk sac. And here you can see the trophoblast and the outer layer of the yolk sac. The trophoblast, we already know the cytotrophoblast, and the outer layer of the primary yolk sac. That together constitute the chorionic membrane. You may have heard about the chorionic membrane that is formed by the trophoblast and the name of that outer layer is the somatopleuric extraembryonic mesoderm. That I already told. The trophoblast divide into syncytial and cytotrophoblast. The embryoblast has divided into ectoderm and endoderm also. Okay, this is the, here you can see the green colored is the syncytial trophoblast. Syncytial trophoblast is actually a layer of cells without a cellular membrane. You can see small dots. These are nuclei. They are well connected. Syncytium means joined, conjoined thing. That is syncytium. So that is why it is termed as syncytial trophoblast. And the cytotrophoblast is the light blue colored thing. And the inner embryo you can see. The neural crust cells that usually termed as a fourth germ layer, even though that is a, because the significant, it is that much important. That is why it is termed as a fourth germ layer. Actually, it is developing from the ectoderm or neuroectoderm. Okay, that we will tell. This is the picturization of the things that is happening. So by the end of second week, this is the thing. I already told that a groove-like structure or line-like structure called a primitive stick that I have shown you, that is happening at the end of the second week. This is the amniotic cavity and the primary yolk cell. That is the earlier cell. By the day of 9 or 10, this is happening. You can see an amniotic cavity and the primary yolk cell. In the primitive sticks, develop a narrow primitive group that ends in a primitive pit. The ectodermal cells proliferate and migrate and forms a third germinal layer, that is a mesoderm. Now we have to think about the mesoderm. Here is a cut section of the things. You can see here is a cut section, that means the upper layer, that is the ectoderm, the middle layer, the red colored layer, that is a mesoderm, and the lower layer, that is a yellow colored layer, that is the endoderm. This is the trilaminar disc that is happening or occurring in the third week of intrauterine life. Then what is happening to the mesoderm? Mesoderm is very much important. You have to know. Questions can be asked from this mesoderm. So the mesoderm can be divided into three components, three parts. The mesoderm, again you can see here the uppermost layer of the ectoderm, the middle layer of the mesoderm, and the lower layer of endoderm. In the center, you can see the notochord. Notochord is directly related to the center of that mesoderm. And we have to know that what are the components or parts of the mesoderm. Very easy to remember. That means the center, that is the axis. The center is the axis. The mesoderm very close to that axis is termed as paraxial mesoderm. The mesoderm close to the axis is termed as paraxial mesoderm. On both sides, there are paraxial mesoderm. They are the outer. That means you can see just outside the notochord or just outside the axis of the embryo, you can see the paraxial mesoderm. Now, the outermost layer of mesoderm, that can be termed as lateral plated mesoderm. So the outermost layer can be termed as a lateral plate mesoderm and the paraxial mesoderm, and the layer in between them can be termed as simply intermediate mesoderm. So that is the naming of the components. The first one is the paraxial mesoderm, the middle one is the intermediate mesoderm, and the outermost layer or the lateralmost layer is the lateral plate mesoderm. These are the three components of the mesoderm, the middle layer mesoderm. What is its significance? We have to know that some derivatives of this mesoderm. That is why it is given. So one more, you can see one more picture of that middle layer of notochord, the layer just by the side of that central axis is the paraxial mesoderm, then the intermediate mesoderm, and the lateral plate mesoderm or lateral mesoderm. These are the three components of the mesoderm. Once again, so now we have to differentiate it into what are the components of the paraxial mesoderm. The paraxial mesoderm, the components of the paraxial mesoderms are, number one, it differentiates into two components. That is the sclerotome, the myotome, and the dermatome. That from the name itself, you can get some idea. The sclerotome. Sclerotome means the cartilages and the bones are developing from the sclerotum of the paraxial mesoderm. So these are the components of the paraxial mesoderm. The sclerotum, then the myotum, the muscles are developing from the myotum, and the dermatom means the dermis or the skin component of is developing from the dermatom. So the significance of the mesoderm is all these components are developing from the mesoderm, and especially the paraxial mesoderm is given to the cartilage and bone, the muscles and the skin. That is the significance. Then the lateral plate, just we are dealing with the lateral plate mesoderm. The lateral plate mesoderm is also divided into 3 components. So I told that the paraxial mesoderm, that is the very much the mesoderm which is very close to the notochord or very close to the axis, that can be divided into sclerotum, myotum and dermatom. In the same way, the lateral plate mesoderm is again divided into 3 components: the somatopleuric lateral plate mesoderm, then a cavity in it, that is intraembryonic coelom, and splaganopluric mesoderm. So the outermost layer or the lateral plate of mesoderm, that is again divided into 3 components, that is a somatopleuric and splaganopluric. So the name itself will give you some idea, and I must give you some idea about what are the components that can be easily related. What is that is the paraxial mesoderm and the lateral plate mesoderm. That means the first layer and the third layer. Just remember it as the first layer as the paraxial mesoderm, the second as the intermediate mesoderm, and the number 3 as the lateral plate mesoderm. So the number 1 and number 3 are functionally related. That means the things, many things are developed from the number 1 layer, that is the paraxial mesoderm. The things which are not developed from the paraxial mesoderm will be developing, or the remaining part of them will be developing from the lateral plate mesoderm. That means the dermis of the frontal region of our body, the skin of our frontal region of our body is derived from the paraxial mesoderm, and the skin of the back and the extremities, that will be developed from the lateral plate mesoderm. That is a significant. Some part of our body will be developing from the paraxial mesoderm. The remaining component of that body part will be developing from the lateral mesoderm. I will give you a very vulgar picture, but still, in order to remember it, you just remember it that there is a connection between the paraxial mesoderm and the lateral plate mesoderm without the knowledge of the intermediate mesoderm. That is a connection. Even though it is an ugly picture, you just remember it as, because ugly things will be remembered low. So now what is happening? The differentiation again into the intraembryonic mesoderm, the paraxial mesoderm, there will be sclerotum, myotum and dermatom. I already told the intermediate mesoderm. So that is a significant thing. The intermediate mesoderm, that give rise to male and female genital and urinary system. That is the most important thing about the intermediate mesoderm. That intermediate mesoderm, that is a layer number 2, that is giving to the urogenital system, both in males and females. And the lateral plate mesoderm, I already told that the somatopleuric and splaganopluric. You may have thought about a particular term there, somatopleura and splaganoplura. So think about that. Pleura means membranes. So somatopleuric and splagano. Splagano means something related to the viscera. You may have heard about splagano myriad times. Splagano means related to viscera. So pleura means membrane. You think about that somatopleura give rise to membranes or layers. That is the parietal layers of most of our structures, or all the parietal layers of our structures. That means the lungs, the heart, that means our pleura, the parietal layer of the pericardium, then our peritoneum. All the parietal layers are developed from the somatopleura, and all the visceral layers are developed from the splaganoplura. That is a significant thing. We can remember it easily. The parietal layers are developing, parietal layer of the lungs, parietal layer of the heart, and the parietal layer of the peritoneum. All these are developing from the somatopleura, and the visceral layers are developing from the splangino-pleura. Splangino means related to viscera. So that is the thing we can remember from that part. So the things we have to know is paraxial mesoderm give rise to skeleton, axial skeleton. So naturally, the axial skeleton is developing from that is the central bones. The bones in the central axis of our body is developing from the paraxial mesoderm. So definitely, the bones of our periphery, that means the bones of the extremities, will be developing from the lateral plate mesoderm. That I told that. So you just think, if axial skeleton is developing from the paraxial mesoderm, the appendicular skeleton means the skeletal bones of our extremities, they will be developing from the lateral plate mesoderm. Then myotome, you may have seen that the striated skeletal muscles, are developing from the paraxial mesoderm. So what are the remaining muscles in our body? We know that there will be skeletal muscles and smooth muscles will be there. So now we can think that the smooth muscles and the cardiac muscles, the remaining muscles, that means the smooth muscles and cardiac muscles will be developing from the lateral plate mesoderm, and the skeletal muscles will be developing from the paraxial mesoderm. That means the component of paraxial mesoderm is myotome. Then the dermis in the ventral portion of our body is developing from the paraxial mesoderm. So the dermis or the skin in the posterior part of our body is developing from the lateral plate mesoderm. That is, the things which are not developing, the components which are not developing from the paraxial mesoderm will be developed from the lateral mesoderm. That is the significance between the connection between the paraxial mesoderm and the lateral plate mesoderm. And the significant part of the intermediate mesoderm is it is giving rise to the male and female genital urinary system. Again, I told that as somatopleural mesoderm and the splanginopleural mesoderm. The somatopleural mesoderm is giving rise to, I told that, the parietal layers, and the splanginopleural is giving rise to the visceral layers. The visceral layer of the peritoneum, the visceral layer of the lungs, the visceral layer of the pericardium. Everything is that visceral layer of the pleura, visceral layer of the pericardium, and the peritoneum. Everything is developing from the splanginopleural mesoderm. So that is a somatopleuric. All the parietal layers are developing from the somatopleuric mesoderm. Dermis of the ventral part of the body and the limbs are developing from the somatopleuric. Appendicular skeleton, I told that the appendicular skeleton is developing from the development of the neural. I told that how it is developing. At first, a neural plate is formed from the ectoderm. Then it fold on itself to form a neural fold. You can see the folding. Then ultimately a neural crust and neural tube is formed. Here you can see a neural tube. That is an electron microscope formation picture. Here you can a golden colored in the upper region. That is the neural crust cells. That golden color or yellow colored is the neural crust cells. And now we have to know, we are going to the systemic component of the embryology. That is, what are the components developing from the neural crust? The questions is usually asked in APGT and other PG examination. Here once again another picture. The neural plate folding on itself, a neural groove, the neural crust. You can see the upper layers are cellular differentiation is termed as neural crust cells. The neural crust, they are developing. What are the things developing from the neural crust? We have to do. These are the components or the structures developing from the neural crust. That is neural crust development. So the neural crust derivatives can be divided into two components: the neural derivatives and the mesenchymal derivatives. Neural derivatives means the derivatives which are directly related to the nervous system or connections with the nervous system. And mesenchymal derivatives means even though it is developing from the neural crust, it has other components also, even not directly related to the nervous system. That they are termed as the mesenchymal derivatives. The mesenchymal derivatives is not developing from the mesoderm. It is the mesenchymal derivatives of the neural crust is here. So all the ganglions. Ganglions means we know that Ganglions are collection of neuronal cell bodies in the peripheral nervous system. Collection of neuronal cell bodies in the peripheral nervous system are termed as ganglions. When there is collection of neuronal cell bodies in the central nervous system, that is in the brain and spinal cord, we term it as nucleus. If it is in the peripheral nervous system, we term it as ganglion. So all the ganglions, that is you may have heard about dorsal root ganglion. You might have heard about parasympathetic ganglions. So many parasympathetic ganglions. Then the sympathetic ganglions. All these are developing from the neural crust. The parasympathetic ganglion, you know the names like the otic ganglion, then the ciliary ganglion, then pterygopalatine ganglion, sphenopalatine ganglion. All these ganglions, the peripheral ganglions or the ganglions in the peripheral nervous system are developing from the neural crust. Then the enteric plexus, the plexus which are connected with our gastrointestinal tract. You may have heard about Orbar's plexus. Then meandric plexus, Orbar's plexus, the relation will lead to, we know, a particular condition. The Orbar's plexus, then meandric plexus, all these are enteric plexus. They are developing from the neural crust. Then the Schwann cells, the cells which are generating the myelin sheath in the peripheral nervous system. The myelinating cells in the peripheral nervous system are termed as Schwann cells. Then the adrenal medulla. The adrenal cortex is not developing from the ectoderm. The adrenal medulla is developing from the neural crust. We know that the adrenal medulla, connection between the adrenal medulla and the nervous system, because the adrenal medulla is secreting two hormones, that is the catecholamines, adrenaline and noradrenaline, and they are the neurotransmitters in the autonomic nervous system. And that is how they are connected. The adrenal medulla and the nervous system connection is there. Then the parafollicular cells in the thyroid gland. The parafollicular cells in the thyroid gland is developing from the neural crust. That is ultimately their immediate progenitor is the ultimobronchial body. UB body means ultimobronchial body. They are ultimately the derivatives of neural crust. Then the melanocytes in our skin, they are also developing from the neural crust cells. That is a direct neural derivatives of neural crust cells. Then the mesenchymal derivatives, we have to know the skull bone except the occipital bone. That is a significant thing. All the skull bones except the occipital bone is directly developing from the mesenchymal, this neural crust. Then the leptomeninges. Leptomeninges, you just remember it as LAP. LAP means first one is A. LAP, you forget the L, A and P. That means the arachnoid matter and the pia matter. That is the AP. LAP. That this arachnoid matter and pia matter is developing from the neural crust, but the dura matter is not developing from the ectoderm or neural crust. Then the dendine of the teeth is developing from the neural crust. The cartilages of the pharyngeal arch, the dermis in the head and face, the conotruncal septum in the heart, choroid and sclera, tunica media of the outflowing vessels, all these are developing from the neural crust. You must study definitely, because questions may be asked. The tunica media of the outflowing vessels from the heart, that is the arch of aorta, then the coronary arteries. The tunica media, only the tunica media of that vessels are developing from the neural crust. That is the mesenchymal derivative of the neural crust. That is a significant thing. You must definitely study the neural crust derivatives. Then some more questions. The cranial, and I already told, the Schwann cells, the satellite cells, cells of pia mater and arachnoid, melanocytes, odontoblasts, chromaffin cells. The odontoblasts, the chromaffin cells, all these are developing from neural crust. So this is just a mnemonic. Everything is not covered in this mnemonic. It is like a mortal pass. M for melanocytes, O for odontoblasts, then T for tracheal cartilage, enterochromaffin cells, laryngeal cartilage, parafollicular C cells, all ganglia and the adrenal medulla, all ganglia. I told that all ganglions. Sir, actually it is ganglia. Ganglions is not there. Ganglia, ganglion is the singular and ganglia is the plural. Then Schwann cells. Then septum. I told you that the conotruncal septum in the heart. All these are developing the mortal pass. Just remember it as mortal pass. Neural crust derivatives. Easy way to remember these things. So this is a structure of an embryo on the 25th day. You can see the head region. Here is a head region. Here you can see a neuropore. We will learn in detail in the neurology when dealing with the neurology. A neuropore. Here you can see some small pouches here. Here it is in the 25th day. Here you can see 2 pouches. On the 28th day, you can see more pouches. It has become 3 or 4 pouches. Now we are dealing with these things, or pouches or arches. What are these things? That is a significant questions can be asked from these things. What are these things? They are the pharyngeal apparatus. Now we are dealing with the next second component of the systemic embryology, that is a pharyngeal arches or branchial arches. Pharyngeal arches, or another term is branchial arches. Why branchial arches means? Sorry, first thing is pharyngeal apparatus. There are 3 components in the pharyngeal apparatus. What are the 3 components? See, just remember it as cap. C for cleft, A for arch, and P for pouch. Cleft, arch, and pouch. These 3 together constitute the pharyngeal apparatus. It should be like that. These are the 3 components of pharyngeal apparatus. So cleft arch means here you can see it is an arch like this structure. Then there will be an outer covering also. That in the outer covering, there are small inner. They are termed as the cleft, and the inner region it is that is termed as pharyngeal pouch. So all these components, this cleft, there are particular derivatives from this cleft, then so many derivatives from this arch, and so many derivatives from this pouch that we have to study, which are the derivatives from each of this component. It is, even though questions and answers is asked, and many a times it will create confusion. So you have to study it simply. What are the structures developed from this pharyngeal apparatus? First of all, we are dealing with the most important in this, that is a branchial or pharyngeal arches. So why it is named as pharyngeal or branchial? Branchial means the head and neck region of the 4th week human embryo look like the same as a, and branchial. That is why it is named as, that is
There are
it look like the gill of a fish. That is why it is termed as branchial arches. Or problem, Deepu. Hello, Deepu. Hello. Hello. Hello, Deepu. Doctor. Hello.
Hello, sir. It's audible. You can continue now.
Okay, okay. Okay. So the pharyngeal arch, what are the components developing from the pharyngeal arches? The pharyngeal arch begin to develop early in the 4th week as the neural crust cells migrate to the head and neck region. That is, It occurs at the same time of the neural crest formation. The first pair of pharyngeal arches appears as on the surface lateral to as soon as the arches appear on the east side of the future. So pharyngeal arches. What are the structures developing from the first pharyngeal arch? So we must know that actually there are 6 pharyngeal arches are formed in the earlier stage of intrauterine life. 6 pharyngeal. One, two, three, four, five, 6. But regress. That is a significant thing. So there will be 1, 2, 3, 4, and 6 pharyngeal arches will be continuously developing. And the pharyngeal arches are separated from each other by a depression called pharyngeal groove or cleft externally. Externally, they are separated by a cleft called pharyngeal groove, and internally, they are separated by a pouch-like structure called pharyngeal pouch. So internally, the arches are separated by pouch, and externally, they are separated from the pharyngeal apparatus, the cleft, the arch, and the pouch. That is a cap. Now we have to deal with what are the structures. In the same way, there will be an arch in the opposite side also. So the first pharyngeal arch, is denoted by, can be denoted by the, what are the things developing from the first pharyngeal arch? The maxillary process. You can see the maxillary process, the mandibular process. They are developing from the, so they together form the major part of component of our face. So the pharyngeal, the mandibular and the maxillary process is developing from the first pharyngeal arch. Then what are the things developing from them? Again, we have to know. So one more thing, you have to know how they are arranged. What is developing from a pharyngeal arch? A typical pharyngeal arch contains, what are the things contains in the typical pharyngeal arch? We must know artery. For each pharyngeal arch, there will be a particular artery for it. We have to study it. What are the arteries for each of the pharyngeal arch? Questions can be asked. Then the second one, each pharyngeal arch contains a cartilaginous rod, and that is the skeleton of the arch. So each pharyngeal arch contains a cartilage. Then each pharyngeal arch has a muscular component. That means each pharyngeal arch produces some muscles. So it has a cartilaginous component, it has a muscular component, it has an arch. So each pharyngeal arch, you have to study the component of in each pharyngeal, cartilaginous component. What will be the muscular component and what will be the nervous component of each pharyngeal arch? That is the question usually asked from that portion. So I already told that this is pharyngeal arch. One more illustrated way, the first pharyngeal, what are the groove, arch or groove or cleft? Externally it is termed as cleft and internally it is a pouch. So here you can see branchial arch 1, 2, 3, 4, like that it is going. This is actual ultrasound number 1, 2, 3, 4, like that is going. Second mandibular arch, hyoid arch, it is like that. Pharyngeal, remember the letter M. Most of the things related to the first pharyngeal starts with the M. What are the things we have to study? You can see the nerve related to the first pharyngeal arch is mandibular nerve and maxillary division of the trigeminal. We know that the tri means 3. The trigeminal nerve is the fifth cranial nerve, and it has three components. That is why it is termed as tri. It has three roots, that is, and three divisions. The mandibular and the maxillary division is deriving from the first. So these are two M's. Then the mylohyoid, then masseter, the temporalis, lateral, and medial pterygoid. You just remember these four muscles: temporalis, masseter, lateral, and medial pterygoid. These four together are termed as muscles of mastication. So the muscles of mastication, again another M. The four muscles together, muscles of mastication. So these are the then another 2-3 muscles, the tensor palatine and tensor tympani. So majority, then again the bones. What are the bones? The malleus, again M. The incus, malleus and incus. Then the sphenomandibular ligament. So everything is related to. So majority starts with the M. So what are the M? Mandibular nerve, maxillary nerve, mylohyoid muscle, muscles of mastication, malleus. All these are M. So everything is related to M. First number one is M. In Malayalam, we can term it as Munne, Mumbai. Mumbai ulladu M. So first one is M. Remember it like that. Everything, most of the things starts with the M. Now, we have to go to the second pharyngeal arch. What is developing from the? So again, I told you that muscles of mastication. That is the masseter, temporalis, lateral, and medial pterygoid. The second one is S. The second, the name itself starts with the S. So the predominant letter in second one is S. What are the S in second? The stylohyoid ligament, the stapes, the malleus and incus in the middle ear is developing from the first arch, and the remaining stapes, especially the footplate of stapes, is developing from the second arch. The stapes, then smaller cornu of hyoid and superior body of hyoid. So hyoid, we know that hyoid is a particular type of bone. It has a greater cornu and smaller cornu. It has a superior body and inferior body. So the things developing from the second arch are smaller cornu of hyoid and superior body of hyoid. You just remember the remaining part of the hyoid bone. What will be that? If the smaller cornu is developing from the second arch, the greater cornu will be from the third arch. If the superior body is developing from the second arch, the inferior body will be developing from the third arch. You can think like that. You can remember easily like that. So the S, stylohyoid ligament, stapes, smaller, superior. Everything starts with the second is the S. S for second, and S is all these things. So the things developing from the second pharyngeal arch, the stapedius muscle, the bone stapes, the muscle stapedius, then stylohyoid muscle, then posterior belly of digastric, auricular nerve. Nerve we will deal separately. So the muscles of facial, that is a significant thing. The muscles of mastication is formed from the first pharyngeal arch, but the muscles of facial expression are formed from the second pharyngeal arch. That you must know. So these are the main group of muscles in the face: the muscles of mastication and the muscles of facial expression. The muscles of mastication is formed from the first, and the muscles of facial expression, because mastication comes from first, then only any expression comes. That means eating is the first thing, so it develops from the first arch. Expressions will be formed only after eating, so that comes from the second. That is second pharyngeal arch. Just think like that. Then the three means that I told that the greater cornu, the smaller cornu is formed from the second, so the greater cornu will be formed from the third. The upper body, the superior body is formed from the second, so the inferior body or lower body is formed from the third. That is how we can remember it. So the third TH, just remember third TH. The important structure developing from the TH is, you can remember it as the thymus. So that I have not written. The third is TH starts with this, just remember it as thymus. The thymus is developing from the third pharyngeal arch, that you have to remember. Then the stylopharyngeus muscle is also developing from the third pharyngeal arch. Then the fourth is thyroid cartilage. Fourth is thyroid cartilage is developing from it. Again, what are the things? The fourth arch forms cricothyroid muscles. So the fourth arch, the cricothyroid muscle, that is important. The cricothyroid muscle is formed from that. Then the thyroid cartilage is formed from that. So the thyroid cartilage, cricothyroid muscle, all these are formed from the fourth arch. Then the all other muscles of the larynx, the intrinsic muscles of the larynx are formed from the sixth. I told that the fifth arch regresses. All other muscles are formed from the, all other muscles of the larynx are formed from the sixth arch. Now we can go with the nerves of the pharyngeal arches. We told that a pharyngeal arch has a muscle component, a skeletal component, then arterial component, and a nerve component. So what are the nerves from the pharyngeal arch? Just remember it like a 5, 7, 9. That is odd numbers. 5 means fifth. Fifth cranial nerve starts from the first pharyngeal arch. The first, it is the first, second, third, fourth, and sixth. The fifth is not there. So just remember it like 5, 7, 9, and 10. So 5 means trigeminal nerve. The trigeminal nerve is arising from the first pharyngeal arch. Then the seventh, the facial nerve is arising from the second pharyngeal arch. Then 9, the glossopharyngeal nerve. It is arising from the third pharyngeal arch. Then 10, we know that vagus nerve. The superior laryngeal nerve. You remember it as the superior laryngeal nerve, which is a branch of the vagus nerve. The superior laryngeal nerve is the nerve of the fourth branchial arch or pharyngeal arch. Then one more nerve called a recurrent laryngeal nerve. That also is a branch of vagus nerve. The 10th cranial nerve is the vagus nerve. So the recurrent laryngeal nerve is the nerve of the sixth arch. Then the superior laryngeal nerve is the nerve of the fourth arch. Then 5, 7, 9. Just remember it as the odd numbers 5, 7, and 9, and 10. 10 has two components, the superior laryngeal nerve and the recurrent laryngeal nerve. That constitutes the nerve of the pharyngeal arches. Remembering it in such a manner that will only give you an idea. Otherwise, it will be very difficult to remember all these things. So 5, 7, 9, and 10, 2, 10. So that is the nerves of the pharyngeal muscles. Sorry, nerves of the pharyngeal arches. Then artery. Artery, we already told the first one is M for maxillary. Then yes, the second one, yes, we already told that it is a stapedial artery. Then 3, remember it as C. A, B, C. C is the third one. So it starts with the C, common carotid artery, and the first part of internal carotid artery. So first one, remember the M. I already told that it always starts with the, many of things are starting with the M, and it is here also it is a maxillary artery. Then the second one is a stapedial artery. Then third one is the third for C. C is the third letter, so common carotid artery. Then 4, just remember 4 can be compared to the letter A. You just continue that slanting part of the 4, you will get A. Remember it like that. That is arch of aorta. 4 can be compared with the A and 4 are almost very similar. A and 4. Remember it like that. Arch of aorta and the right subclavian artery. Arch of aorta is the important thing, and the right subclavian artery is developing from the fourth one. And the sixth one is the pulmonary artery and the ductus arteriosus. Pulmonary artery and the ductus arteriosus. Pulmonary for P, you just make it upside down. The P, you keep it upside down, it will look like 6. So remember it like that. The sixth arch will give the pulmonary artery. So pulmonary artery and the ductus arteriosus are developing from the sixth one. So maxillary, stapedial, common carotid artery, arch of aorta, pulmonary artery. All these are the arteries developing from the concerned pharyngeal arches. Then, so up to now, we are dealing with the pharyngeal arches only. We told that it has 3 components: arch, cleft, and pouch. So all these, what I have told is related to the arch only. Now we are going to the pouch. What are the derivatives of the pharyngeal pouch? Pouch, just think of a pouch. So the same thing you think of your first cavities. The second, that means the middle ear cavity, it is formed from a pouch. It looks like a pouch, and the tube related to it, that is a eustachian tube. So the middle ear cavity and the eustachian tube is really forming from your first pharyngeal pouch. Don't confuse it with arch. It is formed from the pouch. That means cavities are developing from the pouch. Then palatine tonsils and tonsillar fossa. You think about the fossa, tonsillar fossa, and the thing filled in it. You have 2 palatine tonsils. So remember it like that. 2 palatine tonsils. It is deriving from the second pharyngeal pouch. 2 for 2. Second pharyngeal pouch is giving rise to palatine tonsils and tonsillar fossa. Then 3, inferior parathyroid and thymus. So I made a mistake. So actually the thymus is developing from the pharyngeal pouch. Sorry, the pharyngeal pouch, that is the thymus, and the inferior parathyroid glands is developing from the third pharyngeal pouch, and the superior parathyroid gland and the parafollicular cells of the parathyroid gland are developing from the fourth pharyngeal pouch. The fifth and sixth pharyngeal pouches are not that much significant. So these are the pharyngeal pouches. I think it is clear. Now we can move on to the next component. So these are the general idea. Arch number 1. It is also termed as a mandibular arch because mandible is developing from it. It is termed as a second one is termed as a hyoid arch because a predominant main part of the hyoid bone is developing from so it is called a hyoid. So the maxillary artery, stapedial artery, internal carotid artery, right subclavian artery, and arch of aorta. These are the aortic component. That is why it is also termed as aortic arches. Aortic arches also. Then the cranial nerves, told that is 5, 7, 9, and 10. Then muscles of mastication. Here we told it as muscles of mastication, muscles of facial expression, then stylophyllangeus muscle. So all this we have told. Then derivatives of pharyngeal pouch, the middle ear and auditory tube, the supratonsillar fossa, the thyroid and the parathyroid gland, then the thymus, then parathyroid gland, and the ultima bronchial body. So these are the components. I think it is clear. Then some specific components we have to tell. The tympanic membrane, some specific areas. It develops from all the 3 germ cell layers. It develops because it has components of ectoderm, endoderm, and mesoderm. That is a specific unique feature of tympanic membrane. Then some features related to the embryology in eye. The conjunctiva, cornea, and lens are developing from the surface ectoderm. Then the sclera, iris, and ciliary muscles are developing from the neural crust. The sphincter pupillae, dilator. This thing you have to just write down and remember it. Sphincter pupillae, then dilator pupillae, then retina, retinal pigment epithelium. All these are developing from the neuroectoderm. Then the extraocular muscles are developing from the mesoderm. Extraocular muscles are developing from the mesoderm in eye. We already told we saw. Then now going going to the next component, that is the urogenital, the third component in the specific or systemic embryology, that is a urogenital system, the components of the urogenital system. The sex differentiation is a complex process that involves many genes, including same that is autosomal. Okay. The sex of the embryo is determined at the time of fertilization itself. The gonads acquire male or female morphology in the 7th week of development. The gonads actually is not the primordial germ nodes. The gonads is starting its morphological appearance in the 7th week of development. And the gonads initially appear as a ridge, that is termed as a genital or gonadal ridges, that you have to know. So many things are developing from the gonadal ridges. Which are the things developing from the gonadal ridges we have to study. So the gonads appear initially as a pair of longitudinal ridges. And the germ cells actually it is formed in some other part. They will migrate to the ridge. There are so many migrations are taking place in the initial stages of embryonic development. So this migration is also important. The germ cells are formed in another part of the mesoderm. It is migrating from there to the genital ridge. That happens in the 6th week of development. And this is the ridge. You can see a red colored structure here. This is the gonadal ridge here. And you can see a blue colored thing. This is the mesonephros and some relation to some another component, that is the mesonephric duct. And one more there, you can, it is not illustrated here. There is a paramesonephric duct also. So the 3 components are, you have to remember it as the first one, the gonad, and things related to the gonad, the mesonephros, the mesonephric duct, and the paramesonephric duct. We will deal with it separately. So the gonadal ridge, you have to think again the gonadal ridge and the relation of the gonadal ridge and the mesonephros showing location of the mesonephric duct. That is a significant. So the gonads are developing from the gonadal ridges. And one more term you have to know, that is an indifferent gonad. A gonad in an embryo that has not differentiated into definitive testis or ovary is termed as an indifferent gonad. A gonad in an embryo that has not differentiated. It has no particular leniency towards either male or female. That is why it is termed as indifferent. It is indifferent to any sex. That is indifferent gonad. But later that indifferent gonad in males will develop into some particular components. In females, it will develop into other components. What we will study later. So then that are the gonadal ridges. Then the most important structures we have to study is the mesonephric duct and the paramesonephric duct. The mesonephric duct, the another name is Wolffian duct. Wolffian duct. And the paramesonephric duct is the Mullerian duct. These 2 components you have to study. The mesonephric duct and the paramesonephric duct, or Wolffian duct and the Mullerian duct. And one more idea I will give you. The male structures, the important organs of the males are developing from the mesonephric duct. That means M4M. The derivatives of the mesonephric duct are the main genital organs of males, and naturally the paramesonephric duct give out the main structures in the females. That is the most important thing you have to think. That is, what are the main structures in the female structures? The uterus, the cervix, and the fallopian tube. These are the main genital organs or the genital structure in a female. These are developing from the paramesonephric duct or Mullerian duct. And the male structures are predominantly M4M, males, mesonephric duct or wolf. Think about a analog like wolf. Males are wolf. Think like that. All the males are wolf, even though all the males are not wolf. For the purpose of embryology, you think like that. Males for wolf, and the male structures are developing from the Wolffian duct or mesonephric duct, and the females are Mullerian duct. The female structures are predominantly developing from the Mullerian duct. That is the thing you have to. So how it is occurring? there are some structures, some hormones are produced, and they are controlling the formation of these male or female structures. That is the Mullerian inhibiting substance. That Mullerian inhibiting substance, they will suppress the para-mesonephric duct in males. So the para-mesonephric duct in males are suppressed by Mullerian inhibiting substance that is produced by the testis. So that is how the products of the para-mesonephric duct are not seen in males. But the testosterone, they will stimulate the production of the derivatives of mesonephric duct like vas deferens and epididymis. And the external genitalia is also, they are stimulated by the presence of dihydroepisterone. So this is a structure. One more thing we have to study. So what are the derivatives of the mesonephric duct we have to study? The derivatives of mesonephric duct in males are the efferent ductules of the testis, the duct of epididymis, the vas deferens, the seminal vesicles, common ejaculatory duct, ureteric blood, and the trigone of the bladder. So the main structures related to the mesonephric duct in males are the ductules of the testis, duct of epididymis, vas deferens, seminal vesicles. All these are formed from the, that is the main components of the testis, the seminal vesicles, then and epididymis. All these are formed from the mesonephric duct. And the non-functional derivatives, these are non-functional derivatives. These are the superior aberrant ductules of the testis, inferent aberrant ductules of the testis, and appendix of epididymis. These are also formed from the mesonephric tubules. Then, what are the remnants of para-mesonephric ducts in males? We know that the para-mesonephric duct is not producing large structures in males. So there are some remnants of the para-mesonephric duct. What are the derivatives in males are appendix of the testis and pure prostatic utricle. These are not much significant structures in males. So these non-significant structures are only produced from the para-mesonephric duct. And the remnants of mesonephric tubules. So that is the tubules of epiphoron and tubules of paraepiphoron. So these structures are not much significant in females. These are the remnants of mesonephric tubules in females. And duct also epiphoron and duct of paraepiphoron. These are, we know that these are not significant structures in females, but these are produced from the mesonephric duct and tubules in females. That is a significance. So M for males and P for females. Okay. Again, once more, you have to study what are the embryonic structures. The indifferent gonad. I told that the indifferent gonad, it gives rise to testis in male and ovary in females. That is the thing. It gives rise to testis. The indifferent gonad, it contains cortex and medulla, but still the indifferent gonad will give rise to testis in male and ovary in females. So these are the corresponding organs also. The corresponding organ of testis in female is ovary, because it produces, these two organs produce all the male and female hormones in the human body. So they are the corresponding structures, indifferent gonad, and the cortex of the indifferent gonad will produce seminiferous tubules in male, and it produces ovarian follicles in females. The medulla will produce rete testis in male and rete ovary in females. Then gubernaculum testis, you may have heard about a structure called gubernaculum testis, and the gubernaculum is giving rise to gubernaculum testis in males, and it is giving rise to ovarian ligament and round ligament of uterus. These questions can be asked. The ovarian ligament and round ligament of uterus are developing from the gubernaculum testis. Then the mesonephric tubules are developing into ductus efferens in males and epiphoron and paraphoron in females. And now comes the important structure, that is a Wolffian duct or mesonephric duct. It gives rise to appendix of epidermis, ductus epidermis, ductus deferens, ureter, pelvis, collisus, and collecting tubules. But in females, it gives rise to non-significant structures like appendix vesiculosa and duct of epiphoron and duct of Gardner. Other ureter, pelvis, calyces, everything is common. The urinary system is common in both male and female, but the genital structures are different for mesonephric and paramesonephric structures. One more slide for that. The mesonephric duct give rise to ductus epidermis, vas deferens, seminal vesicles, ureter, renal pelvis, connective tubules in male, and in females it gives rise to garson. But think about the paramesonephric duct or the Mullerian duct. It gives the important structures, the tuba uterina, that is the fallopian tube, then the uterus and the vagina. All these are developing from the paramesonephric duct in females. Then the sinus urogenitalis, that is it is giving rise to bladder, urethra, and prostate in males, and the same structures are giving rise to bladder, urethra, and caudal part of vagina in females. That is the difference. So sinus urogenitalis is giving rise to bladder and urethra in both males and females, but it gives to prostate in males and caudal part of vagina. So this is the difference between the urogenital structures in males. So remember the M for males, M for males, and males corresponds to wolf. So then para, usually females are the para. So para give rise to paramesonephric duct give rise to Mullerian, female structures, and it is a Mullerian duct. So again, one more thing, there are some common embryonic structures, and what are the structures developing in both males and females? The middle one is the common embryonic structures. The labioscrotal swelling, the urogenital folds, the genital tubercle, the urogenital sinus. What are they giving rise to? Both in males and females. So the labioscrotal swelling is an embryonic structure that gives rise to labia majora in females. It gives rise to scrotum in males. Then the urogenital folds that give rise to labia minora in females, give rise to ventral aspect of penis in males. Then genital tubercle. It is not the gonadal tubercle. It is a genital tubercle which gives a glans clitoris and vestibular bulbs. It gives rise to glans penis and corpus cavernosum and corpus spongiosum, the penile structures. Then the urogenital sinus, I told you that the urethral and the parietal glands of skin. Then the prostatic glands. The urogenital sinus again giving rise to Bartholin glands in the females and bulbourethral glands of the Cowper in males. So all these can be asked. Anything from this part can be asked. So the genital labia majora, that labioscrotal swelling, folds, anything can be asked. In the reason assertion or like that. So one more important thing is all parts of the urinary bladder except the trigone. So there is a small spelling mistake. So the all parts of the urinary bladder except the trigone of the bladder develops from the endoderm. The trigone develops from the mesoderm. That's also an important thing, a unique feature of the bladder. The trigone, only the trigone in the, we know that the trigone is situated in the back posterior wall of the bladder. That is developing from the mesoderm. All other structures of the bladder are developing from the endoderm. And by that, we are coming to the end of some basic concept of embryology. I know that it is a very boring subject, even during studies or first years. So I think some ideas, you got some ideas, and many of you know good about that embryology, but some ideas can be, you have comprehended some ideas regarding the embryology. And if you have any questions, you can ask now. Hello. I think all of you are sleeping, hearing my embryology.
Sir, they are posting their doubts in chat box.
And then if there is no doubts, we can conclude the session.
Okay. First of all, special thanks to Dr. Sajeev sir for such an informative session on the topic embryology. And thank you all for your effective participation and kind listening that make the session more productive. Thank you all.
And I'm also requesting each one of you to join the CECP this year. Thank you so much.